Good evening. Today I am going to discuss JEE advanced paper as far as maths part is concerned, paper 1, in which you have 20 questions related with different sections and a multiple option. Then you have integer answer correct type and column. Let me start up with the first section, that is the integer answer section, in which the first problem is related with some function, and you have one function given and it's being told that its derivative being evaluated at a plus 2 is equal to area bounded by some other function. Effectively, this is what is the relationship you have in that problem. Area bounded by the small f of x over a 0 to a interval is equivalent to this much, where capital F of x is given to you. So obviously you can figure out what is f dash of a, and you have to then find out what is the value of small f of 0. If you differentiate it with respect to a, you will end up getting this using Newton-Leibniz formula, which is equivalent to f double dash of a, and hence the quantity which you are looking at, that is f of 0, becomes f double dash of 0. And the way f of x was given, if you differentiate that function f of x, you will find that that is related with this much. So effectively we have to differentiate it further, and then you have to put x equal to 0. If you check while evaluating its value at 0, rather its derivative value at 0, if I differentiate this first, keeping this as the first function, you can clearly check the value is going to be then 4 cos square 30 degree, which is going to make it 3 by 4. And clearly you can check when you keep this as a constant, you are going to get whatever value after putting 0 is going to be 0, and the derivative of this being evaluated at 0 is also 0. So overall value is going to be 3. That is what is the ultimate answer for that problem. Okay, in the next problem we have to find out volume given by 250 pi, which is related with some cylindrical container, in which case all you need to do is that, and if you consider this is how the setup you have. If I consider the height of that cylindrical surface as h, you can then check the value what is given to you. The quantity which is given to you is a constant, that is pi r square h, which is the volume of this interior thing, that is the cylindrical volume. This is given to you. All you need to do in this case is that if you consider the content given, that is going to be effectively this is going to be the amount what is required to make such a cylinder is this, and obviously there we have not considered this base. If you consider the base of it, that is going to be 2 pi times r plus 2 whole square. This is what you have to minimize actually as far as this problem is concerned. Based on this statement, if you try to eliminate this h from that relation, and then obviously this v dash is going to be a function of r, and if you differentiate that v dash with respect to r and you make that expression 0, you will find that that required ratio, which is Vy 250 pi is going to be equal to 4, as you will end up getting V equal to pi r of q. This is going to give you that final answer as 4. Okay, next problem is related to combinatorics. There it is given to you that small n is the number of ways in which 5 boys, 5 girls can stand in a queue in such a way that all girls stand consecutively in the queue. Obviously, in such a case, what we do, we take all girls as a single unit. Obviously, there you have 5 person, and if you include all the 5 boys with them, treating this as a single object, you have overall 6 person. Arrangement can be done in this much way, but within that unit, you can arrange those girls among themselves in 5 factorial ways. So this is what is the value of n, and then you have another quantity which is m, that is the number of ways in which 5 boys, 5 girls can stand in a queue in such a way that exactly 4 girls stand consecutively in a row. There what I am doing is I am first of all selecting 4 girls out of 5, which you have to keep them together, and the girl which you are left out, I am keeping that particular girl out from the set. I am going to arrange the remaining boys, after which you can check you have overall 6 different places where you can, there is a girl left out group, and this is the group of 4 girls. Out of those 6 gap between the 5 boys, I am selecting 2 places for these 2. That can be done in this much way, and obviously you can arrange these objects in their places, their selected places, in this much way. Further, you can arrange these girls among themselves by 4 factorial ways. So this is what is going to be the value of m, and ultimately you are looking at the value of m by n. After simplifying this whole matter, you will find that that is going to be equivalent to 5, which is what is the final answer. Next problem is related with probability, and there you have to find out minimum number of times a fair coin needs to be tossed such that of getting at least 2 head is at least 0.96. For this case, I would say it's better if you consider the rejection approach. I mean, if I make this assumption that I have to toss that coin n times and I am getting nowhere head, and then I am getting exactly 1 head, probability of getting such a situation are going to be these 2. If I reject it, this is what is going to be the required probability, but it is given to you that this probability should be at least 0.96. Clearly then this value should be more than or equal to 0.96, which is simplifying to just by trial error you can check you have n equal to 8 as the first number which satisfy this condition, which is what is going to be the ultimate answer for this problem. Fine. Next problem is related with parabola. There it is given to you that at the end of lattice rectum you have to draw normals which are tangent to some given circle with center at 3, -2, and you have to find out radius square. Obviously, if you consider the parameter associated with the end of lattice rectum, that's going to be 1 or -1. If I consider this, clearly then the equation of normal for that parabola where a is 1 is going to be equal to this. Since this line is going to behave like a tangent to that given circle, obviously then perpendicular distance of this point from this line should be equal to radius. So if I square it up, you will have then you will have this expression, which is then simplifying to r square equal to 2, which is what is the final answer for this problem. Next problem is related with definite integral, where function definition is given to you and you have to find out value of this integral. Not exactly value of this integral, this is related to it. since you have f of x square involved and f of x plus 1, where f of x is related to box, obviously then you have to break up this interval minus 1 to 2 into multiple intervals like this. See, the reason why I am taking minus 1 to 0 is in this interval, if you keep x square, you can check, is going to range in 0 to 1. 0 to 1 come back into this category, and there you have a particular greatest integral value. Same thing for 0 to 1. In a similar way, the next interval would be 1 to root 2. Then you will have root 2 to root 3. And then at the end, root 3 to 2. These are the intervals in which you have to split this particular integral because of the discontinuity of that box function. But if you check in minus 1 to 0, since x square is ranging in 0 to 1, this value is going to be 0, which is going to make that whole integral 0. Same thing here. In the interval of 1 to root 2, you can clearly check x square is going to vary in 1 to 2. Obviously then its box value is going to be equal to 1 itself. So that function is going to be x dx. As far as this is f of x plus 1 is concerned, that is going to vary from, since x is ranging in 1 to root 2, you can check x plus 1 is going to vary from 2 to root 2 plus 1, which is coming under this category. So this part is going to be 0, denominator is only 2. That's what you have to figure out in the third case. In root 2 to root 3, you can clearly check that x square goes beyond 2, and when x square goes beyond 2, this definition is going to play a role. Clearly then you can say in this case you will have 0 dx, in this case also you will have 0 dx, because x square is ranging actually beyond 2. Now clearly then the value of this integral is going to depend only on this, which is equivalent to 1 by 4 is the value of I, and you have to find out 4i minus 1 in such a case. Clearly that is going to be equal to 0. The next problem is related to this trigonometrical equation which you need to solve. I need to find out how many solutions exist in the interval of 0 to 360 degree. In this case, since you have double angle involved here of cos, you can check this value cos 4 plus sin 4 is nothing else but this expression. I am actually trying to convert all these two terms, the four terms, in terms of double angle. In a similar way, if you can consider this part, this is going to be, if you treat it like a cube plus b cube, you'll have a plus b as 1, and then as far as a4 b4 are concerned, it's going to be related with this again. So I am making it twice, and then you are going to have negative of sine square into cos square, which is clearly minus 1/4 of sine square of 2x. You can check this 2 is going to take care of that 2, and this expression is going to add up to negative of 5 by 4 of sine square of 2x, implies then you have ultimately this statement, which implies tan of 2x is equal to plus minus 1. Hence you can check in the width of pi there exist two solutions. You can then say overall you are going to have 8 different solutions. That is what is going to be the final answer for this. Next problem is related with parabolic problem, and it's based on parabola. You have one parabola given, you have to find out its image in this line. Whatever image you have got, you need to find out the distance between the point of intersection of that image with some other line, that is y equal to minus 5. If I were to find out image of this curve on that, let me consider a parametric point on this. If I were to look for its image, obviously I can write it in this way. By this you can clearly check, you will end up getting the value of x and y as a function of t. After eliminating t from that pair of equation, you will end up getting the ultimate locus, which you will get it as this, and then you have to find out its solution with y equal to -5. I mean, if you put y equal to -5, you will end up getting a quadratic like this. There you need to find out nothing else but this. This is going to take care of that distance AB, which is equivalent to 4 based on that quadratic, since sum is known and product of the roots are known. Okay, next problem is related with again a parabola. You have one parabola given, and this is related to the multiple option correct section, and there you have to have a pair of variable points as P and Q, such that if you consider a circle whose diametric ends are P and Q, that circle passes through the vertex. Clearly then you can check this triangle is going to be a right angle triangle, since you have 90 degree at this place and it's a diametric end. If I consider a parametric point here, since A is half, it's going to be half T1 square and T1. Similarly, if I consider the parameter of this as T2, clearly we have this information that T1, T2 equal to -4. It's obtained 90 degree at the vertex. And area of this triangle OPQ is also given to you, and then you have to find out the coordinate of this point P, assuming that that is in the first quadrant. For this case, since that triangle is a right angle triangle, obviously then I can write double of that area as base into height, and this distance you can check is going to be this part as far as that part and that distance is concerned, and then again you will have a symmetrical expression. You can check then this product is again -4, which is going to take care of this half along with a minus sign. If I adjust that here and if you square it up, you can check you have that whole thing equal to 72 on that side, and here you have overall 32 plus this much. Clearly then by this you know what is T1 plus T1 square plus T2 square. Using the help of this and this equation, you can figure out what is T1 plus T2. You can then figure out what is T1 minus T2, and hence you can find out what is the value of T1. Just accept those values only which are positive, since P is in the first quadrant, and that is going to give you two options correct, that is A and D for that problem. Okay, in the next problem we have one differential equation that is given to you as this. You have some condition also given there, on the basis of which you have certain options, out of which you have to check how many of them are correct. If you look at this differential equation, this is clearly the exact derivative of obviously then this is going to give you the final solution as, after integrating this differential equation, as in this way, wherein it is given to you that y of 0 is 2, which you can check clearly, that is going to make it C equal to 4. Since y is 2 at x equal to 0, you can check this whole value becomes 4. Hence the value of y is this quantity. First option in that problem was related with y of -4 is 0. Clearly you can check that is correct. The option A is perfect. y of minus 2 is not 0, so option B is incorrect. Then you are looking at critical point in the interval of minus 1 to 0. For that case, you have to find out the value of dy by dx. The value of dy by dx, you can check that is known to you from there itself, but since you are looking at only in terms of x, it's better if you differentiate it using u by v form. You have then I'm not looking at the denominator since that is going to be positive always. Since you are looking at critical point in the interval of minus 1 and 0, dy by dx, if I evaluate at x equal to 0, you can check at x equal to 0, this is 2, that is 4, it is going to be a negative quantity. And similarly at x equal to 1, E will get cancelled off, that you can check it is equivalent to a positive value. I'm sorry, at minus 1 you have to calculate. This is going to be equal to positive value. Clearly then that means, since it's related to the continuous function, minus 1 to 0 you should have a value, you should have an abscissa where derivative is 0. Hence you have a critical point in the interval of minus 1 to 0. Obviously that is going to make the option C in addition to A correct, and this is what is the correct set of answers. The next problem is related to differential equation of family of curves, which is related family of circles actually having center on y equal to x. Clearly you can check a circle having center at y equal to x, say I am taking alpha alpha as the center. Equation of such a circle is going to be like this. Since you are looking at differential equation corresponding to it, you have to clearly differentiate this relation. By this you can check the value of dy by dx is known to you. I'm sorry, not the value of dy by dx, rather the value of alpha, since we have to eliminate alpha. If I differentiate it further, clearly it's going to be 0, and the corresponding differential equation which is going to give you, if you correlate this differential equation after simplifying it with the given form, you will find that p is going to be y minus x and the function q is going to be related with dy by dx square plus dy by dx plus 1, which is going to make second and third option correct in that problem. Okay, the next problem is related to continuity differentiability. There you have so many functions given, and then one by one you have to consider the different, you have to discuss the differentiability of different functions. First case was related with the function f, whose differentiability you have to discuss. You can check this f is nothing else but this is how the function f is defined. At 0, since you have to discuss its differentiability, you have to differentiate it. Both these functions, if you differentiate them, since g dash of 0 is 0, you can clearly check those values are going to be same at 0 also. So function f is clearly differentiable. So that is going to make option A a correct option. Then you have to check h is differentiable at 0 or not. Because of this, clearly you can say that h is not differentiable. So option B is not correct. Then you are looking at a composition f of h of x. Since h of x is always positive, you can check them. Since this value is always positive, there you have the differential value as g of x. Obviously then you can claim this relation as in this way, where since this input is positive, the value is going to be g of that expression. And at 0, when you differentiate this, clearly again you have to define it for positive negative values separately. If you differentiate this further, you can check its derivative for the positive x, for the RHD value, is going to be this much, but for its LHD value, you will have this. And it is given to you that g dash of 1 is not 0 and here x is approaching 0. You can clearly check these two quantities are going to make a difference, because this value is not 0 and this minus sign is going to make a difference. See, it is given in the problem that g is a differentiable function. So g dash 1 certainly exists, but that is a non-zero value. Since this is non-zero, apart from this you can check these two quantities are same. At 0 these two quantities are going to approach towards the same thing, but this minus 1 is going to make a sign change in the two values. Clearly then you will have a sharp corner at this point. So function is not going to be differentiable. This function is also not going to be differentiable at 0. Then you have h of f of x. Again you have to discuss its differentiability at 0. As far as h of f of x is concerned, we have to consider e to the power, then instead of mod of x you have to consider mod of f of x, and f of x has these three different definitions. You can check, if you take positive x, this is going to be e to the power mod of gx, and this is going to be e to the power minus of gx. Since g of 0 is also 0, you can then claim that at 0 its RHD and LHDs are also going to be same because of this condition as well as this condition. Since you differentiate this, you will end up getting both values 0, so that function is differentiable. Clearly then the correct answers for this problem are going to be A and D. Okay, next problem is related with composition, and you have two functions given. Based on this you have to define form, then you have to consider f by g function, then you have to consider graph also, and then you have four different problems based on it. First of all, if you check, since it is given to you that domain of this f is R, and therefore g is also R, you can check that this quantity is always going to range in minus pi by 2 to pi by 2. Clearly then, since this angle is within first to fourth quadrant, I can then claim, if you differentiate it, this whole value, this whole function is going to be monotone. If I consider the range of that function sine of x, now that pi by 2 sine of x, this is clearly going to vary from then minus pi by 2 to plus pi by 2. After this you are taking sine of it again, which is going to make it minus 1 to 1 again. Then you have pi by 6, which is going to make it minus pi by 6 to plus pi by 6. And then you are taking sine of it. Clearly that is going to make it minus half to plus half. This is what is the range of f. This is what is the option A given. So that is clearly a correct option. After this you have to find out range of form. Since f is this and g is this, if you consider its composition, you will find that this particular term, since you are looking at f of g of x, you will have one, instead of x, you will have pi by 2 sine x. You can check that pi by 2 sine x has no role to play. Because of this quantity, since you have got minus 90 to 90, that pi by 2 sine x is also going to make it minus 1 to 1, minus pi by 2 to pi by 2, sorry. Hence, you can claim that range of that function is also going to be the same thing, that which you have got it for f. That is what is given also. So B is also correct. Then you have limit of f by g function. If you take limit of this by this, as x approaches 0, you can clearly check that this whole function f of x by pi by 6 sine of pi by 2 sine x, if I multiply with this quantity, and obviously I'll divide with the same, this value is going to be approaching 1. So this whole limit is getting simplified to this quantity by which I am multiplying here, and with the original denominator, that was pi by 2 of sine of x. Clearly this part is going to make it 1 again. So that limit becomes pi by 6, which is what is given also. So C is also correct. At the end you are looking at a situation wherein GOF is equal to 1 somewhere or not, where x belongs to real number. As far as that composition is concerned, G of f of x, since G of x was pi by 2 of sin x, you can check then GOF is going to be equivalent to pi by 2 of sine of this whole expression. And if I were to find out the range of that expression, means if I figure out range and if I am finding that one lies within it, obviously then this is going to be a correct statement, otherwise it's going to be incorrect. This is going to range from minus 90 to 90, this is going to make it minus 1 to 1, this is going to make it minus 30 to 30, this is going to make it minus half to half. Clearly then this whole thing is going to vary from minus of this number to this number. Now all you need to do is that you have to check whether this one lies within that quantity or not. As far as sine of half is concerned, you can say this safely that sine of half value is clearly lesser than sine of 30 degree, because this is a well-known fact that sine of x is less than x for any positive angle x. There you can check. I have written nothing else but sine of half is less than. Since that is correct, obviously then pi by 2 times this expression is also going to work, which you can check. This becomes pi by 4, which is a fraction. Obviously then you can claim this, that this upper limit of that range is lesser than 1. Obviously then this statement is not going to work for even a single real x. Clearly then D is going to be incorrect and A, B, C are going to be the correct set of options. Next problem is related to vectors. There you have 3 vectors given as A, B, C. Then you have moduli of vector A, vector B and B dot C value is also given, and then on the basis of which you have 4 different statements, you have to check if it's correct or not. The way these vectors are given, you can clearly check that the vector sum of these quantities are going to be equal to null, since starting point is matching with the end point and it is a continuous set. Since you are looking at A dot B in one of the options, that implies clearly you have to take this statement dot with B. Mod B square is then going to be equivalent to 48 here, and then you'll have B dot C, which is 24, equal to null, equal to 0, which is going to give you the value of A dot B as equivalent to negative 72. This is going to make option B clearly correct. Then you have some statement related with, if I start off with the option C, you have A cross B plus C cross A. If I consider it in this manner, you can clearly check after taking A common, you are going to have this expression. Its modulus is equal to some number, you have to figure out its modulus. This is same as then mod A mod of, since you are looking at it, let me make it square first of all. Mod of A is known to you, that value is known. As far as this expression is concerned, you can clearly say that this is equivalent to mod of B square, which is this much. Mod of C square is something which you have to figure out then, which I can find out in this way, that this expression A, if you check, is nothing else but negative of B plus C. By this way, if you proceed, you can check that you have If I ignore that minus sign, you have B cross B null, C cross C null. Then you have twice of B cross of C value, which you can safely say that it is equivalent to this much, which is going to make it equal to 48 root 3. Hence that option C is also correct. As far as B is concerned, that is also correct. Then you have two more options related to mod of C and mod of A, for which case, and if I consider the dot of this expression with C, since A dot C is known to us, A dot C, you can figure it out as mod of C square as 48. The way we have got A dot B, in a similar way we can find out A dot C also. B dot C was already given to you in the problem. So you can check, you have modulus of C square as 48. Clearly you can check that option A out of A and B are correct. You can check then correct set of answers for this problem are A, C and D. It's B which is the only incorrect statement here. Okay, next problem is related to matrices. There you have two different matrices X and Y which are given to you that they are skew symmetric matrix. YZ is given to you as a symmetric matrix. Then on the basis of which you have certain options given depending on X, Y, Z, you have to check they are symmetric or skew symmetric. You have to check, you have to mark only those options which are skew symmetric. And if I consider the first matrix as say matrix A, in the option A you have Y cube Z4 minus you have Z4 Y cube. In order to find out its transpose, you can check even if you take transpose of this whole thing, you will have this expression. But since Z is symmetric, you can say it is same as Z4. Y is skew symmetric, you can say it is negative of it, and because of odd power you will have a negative sign outside. This Y is again skew symmetric, which is going to make it plus. Z is symmetric, so you will have ultimately the same thing. This expression you can check, it is equivalent to the negative of the original statement Y cube Z4 minus Z4 Y cube. This expression is exactly equivalent to A, so you can then check matrix A is equivalent to its transpose, so it's going to be symmetric matrix. Obviously then option A is not a correct statement since you are looking at skew symmetric. In a similar way, if you proceed in for B, C and D, you will find that C and D are the only pair of matrices which are skew symmetric. A, B are. And next problem is related to determinant. There you have a 3 by 3 determinant given, and you are looking at those values of alpha which satisfy this equation. The way it is given, and if you perform various elementary row and column operations, and suppose if I perform this operation, you can check that after performing some elementary column operations, these three you can manage, so that alpha is going to be common. Alpha is going to be clearly 0 out of which. In a similar way, if you take the difference of these two rows and expand, you will have alpha square equal to 81, which is going to make the value of alpha plus minus 9, which are the only options given there. Alpha equal to 0 was not given, so you have correct answer as only 9 and minus 9, which are the options B and C. Next problem is 57th one, which is related with 3 dimension. You have one plane given as this. You are looking at a member of this family, which is P3, whose distance from 0, 1, 0 is 1 unit. If you look at distance of that point, is going to be equal to this much. This is what is given to you. To simplify this matter, you can check, you will end up getting lambda equal to minus naught, substituting which you will end up getting P3, which is going to make it 2x minus y plus 2z equal to 2. And you have one point given as alpha, beta, gamma, whose distance from P3 is 2. Clearly then you can write 2 alpha minus beta plus 2 gamma minus 2 as equivalent to plus minus of twice of root over, you have 9, effectively 3. If you take different signs, you can check B and D are the two options which are correct, other two options are incorrect. Okay, next problem is related to again 3 dimension. There you are talking about a line which is passing through origin, such that all points of that line are at a constant distance from both these planes. You can check this is going to be possible if and only if that particular line is parallel to this line of intersection, and since that distance is constant, obviously then you can check this line you can change its position parallel to itself. That's how the line is variable, and hence perpendicular distance from that line to a particular plane, that is P1, is going to give you different foot of perpendiculars whose locus you are supposed to figure out. So effectively, in order to find out that line, you need to know the direction ratio of this. And if you simplify the matter, you will find that direction ratio of this particular line is going to be, minus 1, 3 and 5. Clearly then the line is going to be like this. And since you are looking at locus of foot of perpendicular of all these points to this plane, if I take that foot of perpendicular as x, y, z, obviously then you can say that direction ratio of that perpendicular is going to be equivalent to x plus r from this, y minus 3r from this, and then z minus 5r from this. But since that line is perpendicular to P1, clearly then these numbers should be in proportion with the coefficients of x, y, z in that equation. So out of this equation, you have to eliminate r. You have two equations, you can easily eliminate r. Then you'll end up getting equation as a linear equation, which is effectively a plane as the locus of that foot of perpendicular. And then you have to check how many of those options are satisfying. You have multiple coordinates given. You will find that it's only A and B which are satisfying that locus, C and D are not. Okay, next problem is related to the column matching one. There you have 4 options and you can have multiple matching possible. Now to make it difficult slightly, and if I start with the option A, where you have projection of 2 vectors, as that projection is going to be equivalent to this much. Its modulus is given to you as equal to root 3, and you have one relation given as alpha equal to 2 plus root 3 beta. Out of this pair of equation, all you need to do is that you have to find out the values of alpha. Once you solve this, you will find that the value of alpha are going to be respectively 2 or -1 depending on plus minus sign here. You are looking at mod of alpha values, which is going to match with then PQ option. Then if I move on to the option B, then have continuity and differentiability condition. If the function is going to be continuous at 1, you can write safely that you have this expression must be equal to b plus k square. Since that is differentiable, you can clearly say then minus 6a is going to be equal to b. Out of this pair of equation, you can easily manage the values of a. If you simplify that matter, you will end up getting the values of a as 1 or 2, which is again going to match with PQ. Next problem is related with roots of unities. If I consider the first term, that is 3 minus 3 omega plus 2 omega square, you can check, you can make this 3 as equivalent to this, clubbing these two particular terms using the fact that 1 plus omega square is 0. You can check this base becomes 1 minus 5 of omega. In a similar way, if you try to convert each and every term in terms of this, you will then find that the whole expression is going to be equivalent to this much. And we can check this is going to be equal to 0 if and only if n is 1 or 2 or 4 or 5. And n should not be equivalent to a multiple of 3 in order to make it equal to 0, which you can check is going to match with then all options other than 3, that is P, Q, S, T. We are left with one more option. That is the option D. In the option D, you have this information given, that harmonic mean of two numbers as this, and then you have one information that B is equal to D is the common difference. Clearly that D you can check is nothing else but 5 minus a, hence you know what is b in terms of a. If you substitute that value here, you can find out a quadratic in a, which is going to give you ultimately the values of q minus a, which is related with twice of d, which is related with b minus a, and b, a are known to you. You will find that this option is going to match with q and t. Okay, in the last problem of this paper, you have a triangle given as far as the option A is concerned. You have the triangle as X, Y and Z. This is how side lengths are given to you, and then you have this information that twice of A square minus B square is equal to C square. And then you have to find out lambda equal to sine of X minus Y by sine of Z, on the basis of which you are looking at the values of n, for which cos of n pi lambda is equal to 0. If you rearrange this using sine rule, you can check this is going to be equivalent to this much, where you can check clearly that this is going to be equivalent to this much. One sine z is going to get cancelled off with this. Clearly then you can check that value of lambda, which is equivalent to this by sine of z, is equivalent to half. When lambda is half, you have this expression. Obviously then you can check for this case, the way those integers are given in place of n on the column 2, P, R, S are the values which satisfy. Then we have second option. In the option B, you have again a triangle with different sides given, and you have one information that 1 plus this statement is given in that column, and then you are looking at all possible values of A by B in that case. If you check, this value becomes 2 cos square of x. And if I rearrange this particular term with this, you can check you have nothing else but one minus 2 cos 2y is going to be equivalent to 2 sine square of y, which is going to be equivalent to sine of x into sine of y, plus you have sine square of x, out of which, and if I consider this into sine rule, you can check A by B is going to, in A by B you are going to have a quadratic equation like this. Hence the value of A by B follows from it as minus 2 or 1, but clearly minus 2 you have to reject. It's going to be only the option 1, which is related with then P. Then we have the next option, that is C, is related with vectors. In option C, and if you correlate this option C with coordinate geometry, I guess it's going to be much better. And once you figure out the equation of straight lines as y equal to root 3x and y equal to 1 by root 3x, you'll find that the possible values of beta is going to relate with P and Q. In a similar way, in the option D, 1 by 1, if you take alpha equal to 1 separately and alpha equal to 1 separately for that problem, you will find that this D is going to be related with this 0 is going to be related with 6, and alpha equal to 1 is going to correspond to 5. So this option D is going to match with ST in that problem.